We have the three different classes. Let's understand by keeping one by one. Right. In the class N, we have written one simple test one method which is synchronized. Inside this, we are calling the wait method. Okay. We are writing another method test2, that is again the synchronized. We are calling the notify method. We'll understand more about the notify method. Then I'm creating a class which is extending the thread, right? So I want to implement the threadness for this, right? So class O has a variable n1 of type n. Okay, so I'm creating a constructor here with the same variable, and then since we had extended the thread class, we need to implement the run method, right? Inside the run method, it is very simple. We are just printing started and then calling the test1 method that is available in class n, and then we are again just simply printing the end. Now we are writing the main class here, n and o manager. The main class, we are creating two objects for class n. One is n1 and n2, and I am creating one object for class O, right, by passing the n1, right, because here the constructor takes the argument of n1 of type n, so we are passing the same thing here, right? O1 dot start, we are starting a thread here, and then again we are starting a thread here, O2, right? And after starting these two threads, I'm just making the thread to sleep for 10,000 seconds. So what does it mean? Sleep of 10,000. It is milliseconds. Whatever you put inside this, it is a milliseconds. That means 10,000 milliseconds is nothing but the 10 seconds, right? So when the program is getting executed, after these two are executed, right, until this is executed, we are saying program to sleep for 10 seconds. We are saying the program to sleep for 10 seconds, and again it will resume, again it will wake up. Okay, after waking up, what are we doing? We are calling the test2 method. So inside the test2, what do we have? Notify method. Clear? So we are trying to start the two threads. Inside the two threads, we are calling the test1 method. That means we are making a thread to wait. Wait is nothing but, if you want to make a thread to wait for some time, we can call the wait method. So thread will be waiting. Once the thread is in the waiting state, if you want the thread to start it again, then we need to call the notify method. Notify means to wake up the sleeping thread or the waiting thread. If you want to notify only one thread, you will use notify. If you want to wake up all the threads, okay, all the threads, then it is notify all method. Notify or notify all. If it is the single thread, you can use the notify method. If there are multiple threads, you can use the notify all method. Clear? This is the meaning of the three methods that we learned in the object class: wait, notify, notify all. Again, as I shown earlier, these two methods also is available in the object class only, right? Object class only. Let's run the program and see the output. See here, started. Now it is waiting for 10 seconds, but this program is still running. After 10 seconds, it will print the end2. See, end. What do we have in the test2 method? Sorry, end test2 method. Notify all. Right? Let's remove one of them. Okay. from where the end is printing, we are calling the test2 method, and we are not printing end in the test2 method, right? But still we are getting end. From where the end is coming? From the run method, right? Let's run the program again. First, o1 dot start, that means it will start a thread, so it comes here, started will be printed. At the same time we are starting another thread, so because of that two threads are starting at the same time. When we call the test1 method inside that, right, we are making a thread to wait, right? When one thread is waiting, other thread cannot enter into the test1 method, right? Basically this is supposed to run for two times, right? Because we are calling two threads, o1 and o2, right? Both the threads are started. Now it is entered into the waiting state. 10 seconds are gone. Now one thread has come out and then notified and called the test2 method, not the test2, this end. One thread has finished with end. Now the second thread also has to print the end. So we need to wait. Here this will be in the waiting state forever, right? Why? Because we are waiting on only one thread, and then we are notifying only one thread, right? Not all the threads, right? The second thread, when it enters into the wait method, we did not notify it again, right? So test2 method is called only once, right? Test2 method is called only once. That is the reason the second thread did not notify it. That is the reason you will not see end now, right? The second thread also has to notify. That means if you want to wake up the second thread also, then you need to put notify all method. Stop it and then rerun. First 10 seconds you will get first end, and after 10 seconds you will get another end. One end has come. Ideally it is supposed to come somewhere, it is never ending. Let's stop and then remove this. but you will not see this kind of programs in real time, guys. This is just for understanding purpose, right? You will not see this kind of things in the real time, but this is one very tricky and difficult and the most complex concept in Java. Try to understand as much as you understand, but if you don't understand fully, that's okay, no worries. It is not moving. Ideally, it should come. It should notify everything, and then we should get the end. We'll see later why it is not, because there is no fixed solution. Maybe it will run successfully the way that we expected if we run the multiple times. Right? Okay, let's leave this. So we can make the threads to sleep, or we can make the threads to wait. So if you want to wake up the waiting threads or the sleeping threads, either you use the notify or notify all method. Notify or notify all method. Notify and notify all. Now let's understand the thread state or the thread life cycle. Okay, thread life cycle. Let's go to Google thread life cycle in Java. You take any one of them. Let's see which one is good to understand. Okay, we need a diagram to explain this. Right. Yeah, I think this is a nice diagram. Can you all see it, right? Even if it is smaller. So now we have seen how to start a thread. That means we are starting something. That means that should have a life cycle, right? When we say life cycle, all the human beings are having a life cycle, right? So they will be in the newborn state, and then the teenage, and then adult, right? And then old age, and then finally dead, right? Similarly, threads also will have the life cycle. There are various stages in its life. Okay, so let's understand what are those states, right? On high level, the thread states are new, active, blocked or waiting, timed waiting, terminated. These are the five different states. Just like a human being have a newborn, or maybe child, adult, old age, dead, right? These are the relevant terminology with respect to the thread and human beings, right? Newborn, kids, teenage, adult, or maybe newborn, adult, sorry, newborn, teenage, adult, what else? Old age and dead. So these are the almost the similar things, right? So let's understand how to reach the each state here. So far we had seen calling the start method on the objects, right? whenever you call a start method, right? That means it is in the runnable state. You see here, this is the starting point. New means whenever you either extend the thread class or implement the runnable interface, that is in the new state, right? In our programs, whenever you just extend the thread class or implement the runnable interface, that means you are in the new state. Okay, when you call the start method, when you call the start method, when you call the start method like this, then it becomes the runnable. Runnable is not part of this thing here. I'll come there. Okay, what is runnable, right? Within the runnable, two different types. One is ready to wait and other one is running. That means once you start the thread, that means it is in the runnable state. That is in the runnable state. That means that is ready to run or that is already running, right? So ready to run, that is one state, and then running, right? So within the ready to run on the runnable, we have multiple stages here, right? So ready to run, sleep, wait, join, right? Forget about this Park Nanos and Park Country. Don't have to worry about it, right? Sleep, wait, and join, right? So sleep is nothing but where what? It is a thread that is sleeping, and wait is what? Some other thread is running, so we need to wait. So one thread is waiting. That means both the threads are already acquired the life. They got the life. They were in the running state. Somewhere they got the instruction to sleep for some time or to wait for some time for the other thread to run, right? We'll come to the join later, right? Those are the two stages. That means if you wake up the thread that is in the sleeping state, that will become running. That means ready to run, right? Sleep method is already born. If you wake it up, then it will be, then it will run, right? That's the reason we consider this as a ready to run. Though it is sleeping, it is ready to run. Wait also same thing. Though it is waiting for another thread to complete its task, it is ready to run, right? Similarly, yeah, basically here there are three different things, right? Timed waiting, waiting, and blocked. Timed waiting means wherever you pause the time to wait or sleep for some time, right? Here in the sleep we are passing the milliseconds, right? That means timed waiting, timed sleeping. We are just saying the thread to sleep for some time, and we are specifying how much time to sleep. Similarly, wait method also. Here, basically in our example, we did not pass any number, but there is another method which takes the argument of milliseconds. See here, milliseconds, you can say it here. 10,000. That means this will wait for 10,000 seconds, right? Sorry, 10 seconds, 10,000 milliseconds. It is stuck. That is the reason whenever we pass the timing, right, we specify the time for how much time to sleep or wait, then it is timed waiting. If we don't specify the time, then it is just waiting, right? When it is just waiting, see the difference between here and here. When we specify the time, after elapsing the time, automatically the thread will wake up and then run, right? Time elapsed, it will go to running state. See that arrow mark here, right? Timed waiting, and then time elapses, then it goes to the running method automatically, right? If you use the without timed, right? If you don't specify any time, if you just call the wait method or sleep method, then you need to wake up those threads. How do you wake up? You use the notify or notify all methods, right? When you do the notify and notify all separately, then the threads will go to the running state. Then the threads will go to the running state. The final or not the final, maybe one level above the final stage is the blocked, waiting for the object monitoring. That means here the thread is completely blocked, right? When this blocked state happens, it happens when we use the synchronization. If you see here, monitor lock acquired, right? That means when one object acquired the lock and then doing its job, all the other threads has to be blocked. We don't allow other threads to enter into the task, right? That means all of those will be blocked state, right? Once it gets the lock, this particular thread, whatever the thread that is blocked gets the lock, then again it goes to the running state. Again it goes to the running state. Once all the states are completed, once the running is completed, what is the final step? That is the terminated, that is exit, right? Exit. First it will be in the newborn state, then it goes into the runnable state, right? Within runnable, either it can be a timed waiting or blocked. Three different stages. If it comes out of these three stages, it will be in the running state, right? Once the running, that means its job is completed, it becomes the terminated, that is a dead thread. That means that is the end of the life here, end of the life of the thread here, right? This is important, guys. So important question that what are the various states of a thread, or what is the thread life cycle. If you can explain by keeping this diagram in your mind, it will be very impressive. It might be a little bit confusing, but by reading it multiple times, you will get it. We don't implement it very frequently, right? We don't mostly see it in the real time applications, but good for interviews. Clear? Any doubts here? Okay, with this, the multi-threading concept is completed. Okay, there are still some more small topics, but your brain will go crazy if you take all of them, right? We'll go with them in the later stage, not at this moment. It will be very much confusing, and we don't use also. This is only required only for the interviews. In real time applications, we don't use or we don't implement all these things, but this much understanding is good enough for the interviews, right? Once you are comfortable with this much understanding, then you can go even deeper in this multi-threading concept, right? But there is no fixed answers, or there is no fixed flow for the multi-threading. It will behave on its own, so everything is correct. Whatever the way that it behaves, that is correct. So in the next class we will start a new topic, right? What is that new topic? Threads is done, object class is done. We will start with we will start with strings. We'll start with arrays. We'll start with arrays and strings tomorrow. Cool, guys. Any questions? If not, we'll stop. Cool. If no questions, we'll stop here. Thank you guys. Have a nice day. See you tomorrow.